Okay, so here we go with the second starter for the A2 Pure Chapter 2.1. Write as a partial fraction. And what I want you to do here is first identify the shape of the answer. And when you've done that, check that against mine before you carry on with the rest of the question. Okay, because otherwise you could do a load of work which is pointless. Okay, so get the shape of the answer first. So the A's, the B's over different bits, whatever it happens to be. Check that and then carry on. Okay, so pause it, try, etc. Okay, so here we go. We have a number of things to do. First, factorise the denominator. And secondly, we've got to also recognise that the power of the numerator is greater than or equal to the power of denominator. Therefore, divide at the start. So they're the two things we really need to become aware of. So if we factorise, first of all. So we get 4x to the 5 minus 3x cubed plus 2x squared plus 5 divided by, well, the first thing to notice when we factorise is that we can take out a factor of x squared to leave 2x squared minus x minus 1. Got a quadratic, so we need to factorise the quadratic, so we get 4x to the 5 minus 3x cubed plus 2x squared plus 5 over x squared, factorise the quadratic, 2x, x, multiply to give minus 1, so it's going to be, one's going to be negative 1 and one's going to be positive 1, and we want minus an x, so it's got to be the minus 1 times the 2x and plus 1. Okay, so now we've got that, we can make further progress. We know that we've got something to the power 5 divided by something to the power 4. So our answer is going to be a number of x's plus a unit plus, we've got a quadratic denominator term over here, so that's going to give us two terms, c over x squared plus d over x. And then we've got two further linear terms. So they're going to give us plus e over 2x plus 1 plus f over x minus 1. So we've got quite a lot of work to do here. 6 constants to find in different ways. So if you've got that shape correct now, hopefully you've checked that against the work you've done. And now we're going to proceed. It would be helpful if you've used the same letters in the same positions. It's not essential, obviously, but it makes it easier for you to check as you go through. Okay, so first thing to do is a division. So we're dividing by a quartic. So we're going to need over here 2x to the 4 minus x cubed minus x squared. So that's what we're dividing by. So we've got 4x to the 5 can go in from our numerator, and then we're thinking about 4x to the 5 divided by the 2x to the 4, so that's going to give us 2x. We can now multiply through, so we get minus 2x cubed, to the 4, and minus 2x cubed. We do not want any x to the power 4s in our original equation. If we look up here, whoops, if we look up here, yeah, we haven't got any x to the power 4s at all. So we've got to get rid of those. Well, we do that by adding them. So we've got 2x to the 4 in here. Okay, so this must be plus 1. Because 1 times 2x to the 4 is equal to 2x to the 4. So we've got minus x cubed here, and we've got minus x squared here. So now we get our remainder. So our remainder is going to be, well, what have we got? We've got 2x cubed minus an x cubed is minus 2x cubed minus an x cubed is minus 3x cubed. So we've got a remainder of 0x cubed. Well, that was quite nice. Here we've got minus an x squared, but our numerator has got 2x squared. So we've got to add 3x squared. And we've also got plus a 5 on the top. So we've now got our a and b. So this is now equal to 2x plus 1 coming from here, and then our remainder 3x squared plus 5 still needs to be divided by x squared times 2x plus 1 x minus 1. And now we're going to use our partial fraction kind of skills to do this section. So we're going to let 3x squared plus 5 over x squared times 2x plus 1 x minus 1 be identical to c over x squared plus d over x plus e over 2x plus 1 plus f over x minus 1. Multiply through by the denominators. Yeah, multiply by the denominator, as we do when we're solving things. So we get 3x squared plus 5 is identical to, so the x squareds cancel to leave c lots of 2x plus 1 x minus 1 plus d, well, one of the x's will cancel with the x squared to leave us d lots of x times, what else have we got, 2x plus 1 x minus 1. Let's just make that a little bit clearer. I'm just worried about running out of space. X minus 1 plus e. So here the 2x plus 1s are going to cancel to leave x squared x minus 1 plus f. And here the x minus 1s are going to cancel to leave x squared and 2x plus 1. Sorry for running out of space down the edge there. Okay. So, what are we going to do to solve this? Well, we've got our usual tricks. So the first thing is to pick a few values that are going to make this easy. So I would suggest the first thing to do is to let x equal 0. So if we let x equals 0, on the left-hand side here, we're going to get 5. And then we're going to get C, 2 lots of 0, plus 1, and 0, minus 1. And all the other terms are going to become 0 because we've got an x here, here, and here. So they will make sure that D, E, and F are 0. Okay, so when we work that out, we've got 5 equals to C times 2 times 0 is 0, plus 1 is 1, and 0 minus 1 is minus 1, implies C equals -5. So we've got one of the 4. What else looks a good value of x to pick? Well, I would suggest x equal to 1 is a pretty good thing to pick because that's going to get rid of loads of terms for us as well. So 3 lots of 1 squared plus 5 is equal to. Now, when I put 1 in here, the C term will become 0. In here, the D term will become 0. Here, the E term will become 0. So that only leaves us with the F term to work out. So those 3 will have become 0. And now the F term, we get F 1 squared times 2 lots of 1 plus 1 equals 1 squared is 1 times 3 is 3, so that's 8 equals F times 1 times 3, so that's 3, implies F equals 8 over 3. So we've now got 2 of these, or 4 of the 6 letters we had at the start. Okay, next we could look at some other terms. So, how about our cubic terms? Cubic. Now the coefficient of the cubic. Well, here we've got 0. This one, we've only got 2x times x, so that won't give us a cubic. This one, we've got x times 2x times x, so that D will give us a cubic. This one will give us a cubic, and x squared times x again in here will give us a cubic. So, let's go back. So the C term we said doesn't give us a cubic. The cubic term from D is 2x times x times x, so that's 2D, plus x squared times x times e is plus e, and 2x times x squared is 2x cubed, so it's plus 2f. Okay, now that's 3 letters, D, E and F, of which we only know one of them. So we can't solve that. So we've now got to think, well, what else could we do? Well, I think the best thing to do is to put in the fraction. If we put in x equal -1/2, there are other ways and you just have to make choices. Some of them are not brilliant choices, but they are the choices that we can make. We can make that bracket 0 by putting in -1/2, that bracket 0 by putting in x equals -1/2, and that bracket 0. And that will enable us to find E. So although the numbers aren't necessarily easy, that looks like the best approach here. So we put in -1/2, 3 lots of -1/2 squared plus 5 equals, the C term we said 0, the D term we said 0, so that leaves E lots of -1/2 squared times -1/2 minus 1. and the f term we said was 0. Negative a half squared is a quarter, so we've got 3/4 plus 5. 3/4 plus 5 is equal to E. A quarter times negative half minus 1 is minus 3/2. Okay, so that becomes negative 3/8 E. And on the right hand side, if we think of that 5 as 20/4, we get 23/4. Usual approach then, multiply it by the denominators. So if we multiply by 8, actually that makes that easy, because the 8, so I've got 8 times 23/4 equals negative 3E. So 8/4 cancel to give 2, so we get 46 equals minus 3E. So E equals negative 46/3. So what have we now got? We've got E, F and C. The only one left to find is D. And we can get at that now by substituting into here. So when we substitute in 1, sub in 1, we get 0 equals 2 lots of D, and I think D is the one we don't know yet, plus E, which is minus 46/3, plus 2 lots of F, which was 8/3. So we've got 2D minus 46/3 plus 16/3. So that's 2D minus 46 plus 16 is minus 30/3 is minus 10. Wow, that came up more nicely than I expected it to. So 10 equals 2D, D equals 5. So we've now got all our terms, so we can finally list out our answer. So take our original expression, 4x to the 5 minus 3x cubed. 4x to the 5 minus 3x cubed. What else have we got up there? Plus 2x squared plus 5 plus 2x squared plus 5 all over, what did we have? 2x to the 4, 2x to the 4 minus x cubed minus x squared, I think. I'll check that. Yep. Now, ax plus b was 2x plus 1. So this is identical to 2x plus 1. Plus our c value, which was minus 5 over x squared. So it's minus 5 over x squared. Plus d, which was 5 over x. So a, b, c, d, e. Minus 46 over 3. Lots of 2x plus 1. And lastly, f 8/3 plus 8/3 of our final factor on the denominator, which was x minus 1. Well, I hope I've got that right, and I hope you get the same. If you spot an error, then let me know and I'll redo it. Okay.